Okay, today is our first attempt at working with what we call domain and range. And for whatever reason, this is one of the toughest concepts to grasp for most people. And it doesn't get any better as you go and get into more complicated graphs. So the best thing we can do is we can start real slow, real small, and we'll talk about how to do it from a normal graph. Okay, so first of all, what is the domain? The domain, by definition, is the set of all numbers that the graph covers on the x-axis. All right? So now it doesn't mean, so it talks about all of the independent variables. It does not mean that it has to be on the x-axis. It's just when you look at the graph and you line it up with the x-axis, what x values are covered. The range is a set of all y values, all the dependent values that are on the same graph. Again, it just is in relation to the y-axis. There are 5 ways in which we can describe domain and range. The first is in words. The second is a number line. The third is interval notation. That's the one we want to get today. And the fourth is set notation, which is also equally as important. There are 2 notations that you will use going ahead. Set notation, interval notation. Knowing both of those is going to be important because when you go into grade 11 and grade 12, you're going to do numerous graphs in which you have to describe the domain and range using one of those 2 notations. And then finally, you can also have a list of values. All right? So the best way to describe this is to start with a number line. And I'm going to draw what appears to be the x-axis. And I'm only going to focus on the x-axis, and we're going to use it to describe what we see. And then we're going to describe it in terms of set and interval notation. So here's how this works. First of all, the one thing you want to know is that if you have a closed dot, that means it includes that value. So for example, if I were to describe what I'm about to draw here, if I were to describe it in words, what values did I just indicate to you? 0, 1, 2, 3, and 4. So I could write that as a set. I could describe it as a set in which I can do squiggly bracket, and I could just list it. Oh, that's good. I'm going to add this in here because I added it today. So that's a list. All right? That's how I would describe it as a list. Okay? Interval notation doesn't really work well with this because interval notation works for continuous graphs. This is what we call a discrete graph in which we have points, coordinates, not connected. Okay? So is everybody following so far? All right. So here's how I'm going to change this now. I'm going to draw a line that connects 0 to 4. Now that I've drawn a line, I am indicating that I am including every single value between 0 and 4, including 0 and 4 because I have closed dots. This is what I want to write for interval notation. Okay? So interval notation works like this. If it's including, I use a square bracket. Okay, so you may want to write this down. Including means a square bracket. The first value is always the smallest possible value on the graph. What is the smallest value that I'm indicating on this graph? 0. Then I put a comma. What is the largest value I'm indicating on this graph? 4. So this set notation, or sorry, interval notation reads every value from 0 to 4, including 0 and including 4. Everybody follow that so far? Always the smallest value to the largest value. All right? In set notation, I would write it like this. Squiggly bracket. N means number, or X, whatever you want. That line straight up and down means such that. Okay, N such that. My smallest always goes first. Is less than or equal to N, which is less than or equal to 4. Now, as we get going, we'll add something to the end of that. N is an element of all our reals. We'll describe that after. Pardon me? Yes. N is just the numbers describing the graph. Now, I can use any variable. I could use X, I could use Y if I'm describing range. But in this case, because I'm just using a number line, I'm going to use N. And all N indicates is all the values between 0 and 4, including 0 and 4. Okay? So I've done a list, I've done set notation, I've done interval notation. Now this is great when I have closed sets like this. Okay? Any questions so far? So this is set notation, this is interval. I got that backwards. No, I'm sorry. I always get these mixed up. So that's what I have. All right. Okay, so let's do another one. Okay, again, does this look like your x-axis? Yeah. So it's going to be exactly the same on a graph when I describe it as my domain. Okay? So, excuse me. Here's what I'm going to do next. Okay, what's the difference between this graph and the first graph I did?
-2 goes all the way to +4.
Nope.
No.
It's not including 2?
It's not including -2. That's the first thing that's different, right? Because it's an open dot. So it's not including that.
Yeah.
What else is different? It's an arrow. It's an arrowhead. Which indicates what? Sean?
It can be anything after -2.
It can be anything after -2. Are all the values in that direction greater than or less than -2? They're all larger than that. We agree?
Yeah.
Okay. So how do I write this up? Okay, well here's the first thing. In interval notation, I use a round bracket because why? It's open. It's not included. Fair enough? -2. Always start small, smallest value to largest value. -2, 2. What is the largest value that this graph has?
4.
No. You see 4, but that arrowhead indicates what? What is it, Cooper? Yeah, it is. Yeah, it is. Cooper's right. Okay? That arrowhead indicates you keep going forever to the right, which is positive infinity. So how do I show that? And an open bracket. Infinity is non-inclusive, ever, because you actually never get there. So it's an open bracket on infinity.
This is interval notation.
This is interval notation, right?
Yeah.
Okay. Set notation now. How do I show this with set notation? I'm going to use X this time. So I put X such that. Okay? X such that. Somebody describe that to me in words, please. Describe that graph in words. What am I showing?
There's a number, and then, I can't remember why, there's a number and then.
Okay, don't ignore this. All I'm asking is this.
Oh,
Anything greater than -2, not including -2.
Okay, yeah, right? Isn't that what I'm saying?
Yeah.
I'm saying I want to include every value greater than -2. Not including -2.
Yeah.
So not equal to. So how do I show that here? X is greater than -2. Correct?
Yeah,
Does that describe my graph?
yeah.
All values greater than -2. That's what I drew there. Is that not what I drew? Yeah?
Yeah.
Okay? Okay,
If that dot on top -2 is filled in though, it would be including, wouldn't it?
right.
So
So then,
equals to this.
no? Okay, how does that, okay, well, let me finish this and then I'll go back to your question. I'll change it, okay? So, here's what happens. I'm gonna add something to the end of this. Okay, so you need to watch this. Okay, so funny little notation. X, that rounded E means element of, and that R with a line through it, all real numbers. What does that mean? Every irrational and rational value greater than -2,
because it doesn't stop.
because it doesn't stop.
But
And it's continuous, which means it hits every single value. The square root of 3, the square root of 4, pi, 10, 1 million, all the way to infinity. It includes every possible value you can have. Understand?
So why can't you just put infinity?
Because I don't use it in this notation. I only use it in that notation. Okay? So, just wait. I'm going to answer your next question, because I know what it is already, because they just asked. So, everybody understands this part so far?
Yeah.
Okay. So how does it change then if I do this?
In.
So how does my notation up here change, John?
You have to change the greater to equal or greater.
Okay. Sure. So x such that x is greater than or equal to. That means it implies that it's also equal to -2, where x is an element of all reals. Now, x is an element of all reals is going to be very, very huge for you as we go. Because when we describe a lot of graphs, we're going to do it as x is an element of all reals. Any line, any linear line that has got arrowheads on both ends means that it's x is an element of all reals. That's your domain. But we'll come back to that. So now, how does this guy change then? How does that notation change by me filling in that dot?
It's not going to be in the
What is it going to be?
including one,
Okay, which is what?
the box.
Square. Right, yeah, that's fine, box. Sure. How does that look? That now becomes this -2 to infinity.
And then they do this,
What's that?
they would, the closed bracket would be on this bracket.
Closed bracket would be,
After infinity, yeah.
this guy is always going to be not included for infinities. Okay? So in the first one we did, they were both closed, right?
Yeah.
Because it stopped, right? And it included that value. But we don't ever include infinity. You can't get to infinity. So it's always a round bracket when you use infinity. Is everybody following me so far?
Yeah.
Yes, Sam?
But that closed circle is X, right?
No, X is any value from there, along that line. X is any value along that line.
Or so you could say like Z or Y.
Or Z or Y or N.
Okay.
That's what I said the last time we did this question.
Yeah, I was
Just clarify? Well, that's good, Sam. Ground safety. Go ahead, Bob.
where are you getting the one from in the equation?
The one,
Yeah, line.
Oh, the line.
this line,
Yeah, what's that for?
that says, that means such that. It's just math lingo. So when I put X with a line down, it means X such that this is what it means. So it's an actual, that's what it means. It's that
Okay, so
It's a
it's
symbol
basically
that-
meaning like X
X is equal
is
to
equal to this.
this, yes.
Okay.
But not in set notation, we say that it means such that. X such that this. Okay? How are we doing so far? We're all right? Okay? Check another one out then. Like I said, this is one of the more difficult things that we end up doing. All right, so I'm gonna throw, no, not yet. Okay. In words then, describe to me this graph. Liam?
Everything lower than minus one, including minus one.
Good, not bad. Anything lower than or less than, right? That makes sense? We're gonna use less than and greater than. Anything less than -1, including -1. Because why? Otherwise it's including. How do I know if it includes or doesn't? Bodie?
Dot's closed.
Dot's closed. Right? Closed dot. That's how I know. How do I know it's going forever? Right? Alright, so let's describe this. So, what is the smallest value that I need to describe? What do you have? Is that the smallest value?
No, it's negative infinity.
Negative infinity. Exactly. My smallest value is negative infinity. Sammy, what is my largest value?
-1.
-1. Right? They're all smaller than that. So there's how my notation looks.
Does it matter what we're doing?
Yes, Lexi. Yes, it does matter. It's always the smallest, comma, the highest,
Okay.
the largest. Yes.
Why is one bracket curved and one square?
Because one's including and one's not including.
Okay,
You can't include infinity.
because it's not on the graph.
Because it theoretically is on the graph. It goes, negative infinity is somewhere out here. Right? But I can't ever get to negative infinity. It keeps going forever.
Yeah.
So I don't include it. Okay? But -1 is inclusive. Everybody's okay? Alright? So now, I'll do it this way. Y such that. Okay? How do I describe this?
Y, negative infinity, less than negative.
Okay, you can do it that way. I don't want to. But you can do it that way. What the girls are saying is this. Minus infinity, less than or equal to y, less than or equal to -1, right? Okay, that works. I don't want to do it that way. Okay, and that's fine. I would mark that incorrect. But the correct way of doing it is a little bit smoother than that. I don't want to put the infinity value in there. This is why I ask you, how do you describe it in words?
Oh, the X,
What's the y?
Jake?
You just put y is less than or equal to -1.
Yes, that's all you have to put. Y is less than or equal to -1, right? That implies that y is smaller than what that -1 is. That's what it means. Y is smaller than -1. Covers all of those values there, does it not? Is -100 in there?
Yeah.
Sure, is that smaller than -1?
Oh, yeah.
Yeah.
You never want us to use infinity for this one?
In this notation, I don't. I mean, if you do, you do, but I prefer not, no. Okay, and then I also have to add in, because I'm using every single value all the way through here, I'm also gonna add in y is an element of all reals. Okay, that'll make more sense to you when we start doing problems and you have to use whole numbers and integers. We'll get to that after. But right now, all I need you to do is be able to describe in words and then those two notations what you're seeing there.
How do you see that?
How would I say that in words? I am going to use every number less than -1 or equal to -1. Right?
Yeah.
What does the graph cover? It covers every single value less than or equal to -1. Okay, in the book, they would say, all right, they say all integers, but we're going to use all values equal to or less than -1. Okay, that's what that means. We following this?
Yeah.
Okay. We ready for a tricky one? Are we ready for a tricky one? Are we ready? Maybe. All right, well, we'll find out real quick here.
Oh,
Okay. So in words, describe to me this graph. Kelsey?
Would it be -3, including -3, is less than 3, -3, and then
All values less than or equal to -3? Yes. And? Or all values greater than 5, including? Not including.
So this is both
Right.
for the same variable?
This is for the same variable.
Yeah.
You're on the same axis here, right? Right? That's all it is, right? So, but this is where it gets a little complicated. How do I show this? Well, here's how I would show this. X such that x is less than or equal to -3, comma, that separates it. X is greater than 5. Okay? And then x is an element of all reals. There you have it. I wouldn't use the other notation for this. I can, and I will show you in a second how to use the other notation. But this is the notation you would use to describe it. X is less than or equal to -3, or x is greater than 5.
So for like anything like including infinity or whatever, you just put x to the element of all reals.
Yeah.
At the end of
Well-
the notation.
Let's do that again.
that
Any continuous line.
Yeah.
Okay, so that means it goes through every spot, right? Because from here to 6, it's going to cover every value in between, rational or irrational. So yes. All right. I'll show you after an example where you don't use all real numbers, and that's where you have dots.
Oh, right.
Where they're not
I remember
connected.
that at the beginning.
Okay,
So
there
there
isn't
isn't an arrowhead, or there isn't like an arrowhead?
that's right. And there's no line. It'll just be dots connected.
Is that easier or harder?
No, it's no different. You can there's 2 ways. I'll show it to you next. Okay. Okay. All right. So far we okay? Now don't write this down. But if you were to show this, now this is where I get confused, because when I do this in grade 11 and 12, I have to look this up. Because to me, it should be or, but some books say and I don't know which, so I'm going to show you the notation. I don't suggest you do it for this guy. I like that guy. So here's how it works. What's the smallest? If I'm just describing this part of the graph, what's the smallest value? Negative infinity. So I go negative infinity to my largest value in this part of the graph is -3, including, right? Okay. Now you can do or, which is my preference, But some say and, meaning it has to, but I'm gonna use or for now. Now how do I describe this part of the graph? What's my smallest value on this part of the graph? 5 is. Including or not including? Okay, so it's rounded bracket, right?
Yeah.
And where do I go to?
Positive infinity.
Positive infinity, good, Cooper. Here we go. Okay?
Will it ask for us to do that?
But it will ask specifically to do set notation and interval notation on your test. So you do need to know both. Okay? And as you get into grade 11, you do what you're most comfortable with. But for this year, we're going to do both all the way through. Just so we get used to both. Okay? Alright, so like I said, I don't need this. I'm not too worried about that right now. That's not what I'm worried about. I'm worried about the first part there. Okay, so let me show you. This goes back. And actually, let's go right back to the beginning. What was the very first thing I did before I did all that? Oh, no, let's do this again. Okay, so here we go. So Bobby Joe. This, and this. Actually, you know what? I'm not. I'm moving them all closed, because that's the way it's going to work. So that's closed off. Okay, so I have 5 dots here, correct? Oh, 6. Can't count. 6 dots there, right? So to describe this graph, there's a couple ways to do it. X such that I could go -3 less than or equal to x is less than or equal to 2. Again, Lexi, I do smallest to largest all the time. That way you never mess it up. You always start with your smallest on the left and your largest on the right. When I describe this to you in grade 11, because you can't remember what domain and range is, because most of you won't, I say, what's the furthest point on the left the graph touches? What's the furthest point on the right it touches? That's what you have to describe to me. Then what's the furthest point down it goes, and then the furthest point up it goes. So it's left to right, down to up. That's the best way to know domain and range. Okay? So here's how I got this. Why? Am I including all these fractions and decimals in between? I'm not, am I? So how do I write it? X is an element of the integers. The workbook or the textbook will use Z sometimes to represent integers. What is an integer? Actually, you know what? I'm going to go back. I want to go through this. I forgot to do this, so I'm going to do it right now. Let's go through our number system. What are the natural numbers? What are all the natural numbers?
Like 1, 2, 3, 4, 5.
Sure.
6, 7, 8, 9, 10.
Okay. Good for you. Right? All the positive whole numbers. That's what it is. What are the whole numbers? That's the next biggest.
If you want to include any number with a decimal, like below the decimal.
Well, that's what natural is, though, right? So what's the difference between natural and whole?
Whole can be divided by itself. Never
And
mind,
whole,
one down, one.
any number can be divided by
Oh,
both
gosh.
sections. Both can be negative.
Can't be.
Is there a difference?
I have 1 donut. Can I have a negative 1 donut?
No.
1 whole donut. That's what I get. Can't have a negative 1, can I? No. So what is the difference between natural and whole?
Whole has to be equal.
Can I have 0 donuts? Is that possible? That's a whole number. So the only difference between the two is this. Whole numbers include 0. That's the only difference. Okay, so far? You might want to write this down. This is going to be important to you.
So does that mean that natural can be negative as well?
No. No. Natural is 1, 2, 3, 4, 5, and so on. That's what I said, all the positive whole numbers. Integers now, the next largest set of numbers. Integers is the next largest set of numbers. What does the integers include that the whole numbers do not? Negatives. But again, only number, this number is only going to be divisible by 1. Right? It has to stay as is. Integers minus 2 over 1, minus 1 over 1, 0 over 1, 1 over 2. So there's nothing else you can do to it. Those are just whole numbers, but negatives as well. Fair enough? Okay, any questions so far? All right. Then there's this. This incorporates all of it. Real numbers. Now the real goes beyond just this. It goes beyond just that. What have I shown you so far is all the negatives and positive whole numbers. The reals also include decimals, rational and irrational. The whole system is that. So let me just take I think there was a picture in here. 74. 74? Thanks. Good find. Okay? Take a look at page 74. So you'll see the real number system is the largest. That includes all rationals. Rational numbers are integers, natural, whole, right? And rational numbers that can be put in the form of decimals. Terminating decimals or repeating decimals. Irrational numbers, non-repeating, non-terminating decimals. So non-repeating, non-terminating decimals, those are irrational numbers, like square roots that aren't perfect squares. Okay? So that shows you how it works. What's the smallest number system in there that you can see?
Natural numbers.
Natural. And then what's the next largest? Whole. And then integers. And then together, all of that with rational and irrational make up the real number system. So when I draw a line such as this, I'm including every possible value. Every possible value. Okay? All right. Any questions so far? Okay, I'm going to give you one graph, and then I'm going to let you work. I'm going to give you one graph, and I want you to see this graph, and I want you to help me with the domain and the range, with what I just told you. Now remember, here's my x-axis, here's my y-axis. When you describe domain, when you see arrowheads like this, that means they go out forever. So in this case, they're going this way forever. And this way forever. That's what those arrows mean. Got it? So knowing that, the domain for this graph. The domain for this graph is what? What's the furthest left that it goes? What do you have? Furthest left it goes? Negative infinity. What's the largest to the right it goes? Positive infinity. So to write that, you could go this in interval notation. Negative infinity to positive infinity. Because that graph goes out to the left and out to the right forever. Got it? In set notation, here it is. Everybody watching? In set notation. That's all I need. X is an element of all reals. That describes every value going to negative infinity and every value going to positive infinity. It describes that. X is an element of all reals means every single value is going to be covered. Now, if this graph is continuous and it goes out like this forever, that's your domain. That is your domain. How about your range on this graph? So now, the range is the set of all the y values that this graph covers.
Domain is horizontal.
Domain's horizontal, range, y values, vertical. What is the smallest y value that this graph touches? 0. Include?
Yeah.
Yes. It will have an open dot if it doesn't. So 0. And what is the largest value that it goes? Y. What is it? It goes to positive infinity. Like that.
And then you would just put or and.
Nope, we're done.
Okay.
That's it. Because it's connected. Right? If it was or and, it means I have a disconnected graph. Remember in this other graph that I did or and for? Was because I had part of it going this way and part of it going that way.
Yeah.
What I have on this graph, if you were to look at it, it would start here and go this way and start there and go that way forever. So it's connected. So I just have to put back one. So I just have to put 0 to infinity.
Okay.
How did I describe that using set notation? Y such that
Greater than, or X is
no, it's Y.
greater than.
It's gotta be Y because
Y is greater than or less, or n equal to 0.
Yes. Y is greater than or equal to. What's the smallest value on the graph that it covers? 0. Y is greater than or equal to 0. And then Y is an element of all reals. Like that. There's your range. I've described my domain and my range on this graph.
Do you have to put them together somewhere?
Nope. They're always going to be separate. And you do them exactly as I've shown there. Domain, and you can do, and like I said, you need to know both notations right now, but as you get into grade 11 and 12, you need to know one of those in order to do this. But right now, you need to know both notations.
So integral notation is probably easier.
If you have a connected graph, a continuous graph, then yeah, for sure. But if you have a discrete graph, then set notation is easiest. Yeah, discrete. Okay? Alright, I'm not giving you anything else. Are there questions from yesterday that you need to look at? This is hugely important. I can't stress this enough. Alright, I've been saying that all along for certain things, the radical part, the polynomial part. This is another thing that carries with you, and this will carry you with you into university. You need to know domain and range in university. You need to know it. You've got to be able to describe graphs. Okay? Any questions from 6-2?
I have one for 117,
Yeah.
9A.
Yeah.
It says, which is revenue, which is cost. How do I know?
Okay, well, one of those lines starts at $4,000, and the other one starts at 0.
So it would cost going to pay money to start.
They cost me $1 and
Well, they're both dollars, right? But which one starts at 4,000 and which one starts at 0?
So gray one starts at 4,000.
Okay, and what does it represent? Does it represent the revenue or the cost? What is the difference between the two, Sammy? What does cost mean?
Money that you have to pay. Revenue is money you make.
And the money you make. So if you have 0, if you sell 0, are you going to have a cost or are you going to have a revenue? Cost, because you can't make any money if you don't sell them, right?
Oh, for blacks.
Right. Okay. Any other questions? All right. We've got the remainder today to work on this and process it.
Do you want us to do 6.2 or go straight to 6.2?
No, 6.2 and 6.3 can be done today. I won't go into 6.4 tomorrow.